Hello everyone, my name is Glenn Evenbley and I'm here today to give you a quick introduction to the TensorTrace software I've developed for making tensor networks. Okay, so tensor networks are these useful constructs for representing data used in quantum physics and machine learning and big data analysis. Okay, so they're very useful, but at the same time they can be very labor intensive to actually program these constructs. So the whole purpose of TensorTrace is to simplify and streamline this process. Okay, so here is the TensorTrace app, and I can create a tensor just by clicking and dragging. Okay, so here I have a 3-index tensor. I can give this a name. Let's call this A. Okay, so this represents a 3-dimensional array of numbers. Okay, where graphically we have the first, the second, and the third index. Okay, represented by these tabs. So I can move these tabs around if I like. Let's just keep them where they are. And we'll make a second and a third tensor. Okay, so I'm going to call this one B and this one C. So these are all 3-index tensors. And I can combine them into a network by simply clicking on one of these tabs and clicking on another tensor to join it, to join an index. Okay, so now graphically what this represents is the second index of tensor A is now contracted with the first index of tensor B. Okay, so let's click everything to form a complete network. I can also click a tab and click on an open space. Okay, so this represents a free index of my network. So the first free index, the second free index, and the third free index. Okay, so we have 3 different tensors contracted together by 3 different indices. The output of this contraction will be a 3-index tensor with indices 1, 2, and 3. Okay, so I've drawn this in TensorTrace. So the main feature of this software is that it allows me to easily export this network I've drawn into code. Okay, so the easiest way to do this is to simply select the network I'm interested in. I can Control C to copy and then Control V to paste into a text editor. Okay, and you can see TensorTrace has generated the code that would allow me to contract this network. Okay, so currently it's configured for Python. However, in the config you can choose between Python, MATLAB, or Julia code. Okay, and you can see I can actually, this code is configured to initially generate some random tensors for A, B, and C. And I can run this code snippet and it will actually produce my tensor T out, which represents this 3-index tensor from the contraction of this network. Okay, and we also have some other useful information. For instance, the cost of contracting this network, we can see scales as the bond dimensions of the 5th power. Okay, and when I actually select and copy my network, TensorTrace also actually examines this network. It looks for the optimal way to contract the tensors, so it has some built-in solvers that actually does a lot of work and actually figures out the optimal way to contract this network, which is produced in the code. Okay, so the code you produce, is not only an accurate representation of what you're trying to contract, but is also a very efficient way to contract this network as well. Okay, and what you can see is additionally with the pasted data, there is this string of sort of random symbols. So what this is actually some metadata which actually contains information about the diagram itself. And what this allows you to do is I can actually copy and paste from the code back into TensorTrace, okay, to recreate the diagram. So you can imagine what I have in mind for this is this could be a useful feature. For instance, if you're looking at some complicated code, one of my codes you've seen on GitHub, if I just look at some contraction, this is very complicated. There's no way I'd be able to understand what's going on in this contraction just by looking at the code. However, I can copy and paste this back into TensorTrace, and you can actually see the network associated with this code snippet. So this allows you to sort of easily modify a code you've been working on at some later date. It allows you to look at someone else's code and interpret the diagrams and possibly modify the diagrams in a very simple way. Okay, so I could change this diagram in some way, and then I could copy and paste back into the code if I wanted to, for instance. Okay, so this is sort of the quick start guide to TensorTrace. I have another tutorial where I go into sort of a more in-depth feature. In particular, there are ways to generate, rather than copy-paste, you can actually export a set of tensor networks into a function file in your chosen language, for instance. Okay, thank you very much.